Alright, so today we're going to be talking about logarithmic functions and just using them and all that kind of stuff. So as a warm-up, pause this video and solve each of these without your calculator. Okay, so to solve the first one, we got to think of 2 to what power gives you 16? Well, 2 squared is 4, 2 to the third is 8, 2 to the fourth is 16. So here x is going to have to equal 4. Now we have x, or 10 to the x equals 0.1. Well, we want it in terms of 10, so I'm going to rewrite this as 1 over 10. Now, we still have 10 to the 1 right here, but it's at the bottom. So to get something from the top to the bottom, you have to have a negative. So x is going to be equal to -1. Here we're on the bottom again, so obviously we need some sort of negative exponent. We want this in terms of 3. So how can I rewrite this in terms of 3? Well, we have 1 over 3 squared. And again, we're on the bottom, so this needs to be a negative exponent. So you have x equals -2. Here we can rewrite our cube root of 5 as a fraction. So we do 5x to the 1/3. Well, then this x and this have to be the same. So x is 1/3. Okay, so what is a logarithm? A logarithm is some quantity that represents the power of the exponent to which a fixed number, the base, must be raised to get a given number. So it's kind of like looking over here. All right, logarithm gives us these x's. So it tells us if we have some base, so 2. So if I have 2 and my answer is 16, the exponent had to be 4. You're kind of working backwards. So b is your base, n is your exponent, and then this is just like whatever the number is they give you. So an example of BuzzFeed was like 16. So it's a way to find exponents instead of like plugging in an exponent and finding the answer. There's 2 common bases we use. So one of them is 10 and one of them is e. We talked about e a couple videos ago. So base 10 is called the common log. If you ever see something written without a base, it's base 10. And then the natural logarithm is base e, and this is an ln, not an x. I know it kind of looks like an x, but it's log base e, and you just write it as an lx. Both of these are on your calculator. So if we go to the calculator, when it pops up, here is the log button, and then here is the ln button right below it. Okay, so if we keep going, how do they relate to each other? So graph each of these and look at the graph and think about it for a bit. Okay, so if I sketch the graph, this won't be 100% accurate. We'll get something like this and something like this. So this is your 10 to the x, this is your log to the x. And these look about the same. If you notice here, if I draw in the line y equals x, these are reflections over this line. So you go back to chapter 1, I think it was, we did inverses. These are inverse functions. So logarithms and exponentials are inverses, which means they undo each other. You switch the x and the y, they undo whatever the other one did. So how do we actually switch between them? So logarithmic form, here's our base, there's our exponent, here's our number. Exponential form, you have the base and the exponent on one side, and your answer is some number, whereas here your answer is an exponent. So an easy way I remember how to switch is by doing a loop. You can just memorize these and do it that way, and that's fine. Or think through logically, like what does it have to be? But if you make a loop, you want to start at your base always, and then end at your exponent, or end at your, like around the equal sign. So start at your base, go around the equal sign, end at whatever's left. So then if we were going to write this as an exponential, we start with the base, so this is our 1, then we're looping around, so now we hit the n, and then we end at the a. So start at the base, go around the equal sign. Here we start at the base, go around the equal sign, so you have log base b of a has to equal n. A note here, if we're doing this, but we're doing it the opposite direction, so say I had n equals log base b of a, you still want to start at the base, go around the equal sign. So it's going to be backwards loop so that you can still get the same thing. So pause the video and try these on your own and practice switching between the two. Okay, so if you draw the loop, we start at the base, so 2, go around the equal sign, equals 8. And you can check this, 2 to the third is 8. Going the other direction, start at the base, go around the equal sign, and get to the other number. So we want log of our base of 10 of 1,000 equals 3. And then this one you could not write the 10 since it is a common log, it's up to you. Same idea here. We want 3 to the negative 2 equals 1/9. Loop around. Log of your base of 4 of 64 equals y. Okay, so what do you actually need to do with that? So we're going to try and evaluate these without a calculator. So what that means is you can rewrite it as an exponent and do what we did on the first page. So we know these have to equal some x. So if we do the loop, you get 3 to the x equals 1 over 27. So now we want 27 in terms of 3, so we can figure out what that exponent is. So 27 is 3 cubed, so this is the same as 1 over 3 cubed. And then because we're now on the bottom, this would be the same as 3 to the negative 3. So these have to be the same, so x equals negative 3. We're going to keep doing the same idea, so rewrite this. If we do our loop, have the x right there. 3 to the x has to equal the 5th root of 9. Well, we need to rewrite that 5th root. So I can rewrite that as 9 to the 1/5. But then you need to rewrite the 9 in terms of 3. So we'll get 3 squared to the 1/5, which is the same as 3 to the 2/5. So x has to equal 2/5 in this case. And then we're going to keep going here. So we can rewrite this as equals x. Do your loop. There's nothing written, so it has to be 10 to the x equals 100. Well, that's just 2, since 10 squared is 100. Do the same loop here. E to the x equals 1 over e, which is the same as e to the negative 1. X equals negative 1. All right, so another way to quickly evaluate these without a calculator, you can redraw this. So we could rewrite this when we get 10 to the x equals 10 to the 14. Well, then x equals 14. So that's going to work for all of them. If your base of the log and the base of your exponent are the same, they just cancel. So this cancels out and we get 14. These cancel, we get 14. These cancel, we get 5. These cancel, we get 5. We get 6, and we get 6. So a base of 3 and a base of 3 cancel. A base of e and a base of e cancel. This is because they're inverses, so they undo each other. Okay, so some matching here. Here's our original log of x, and then we want to match these to it. So here we have log of x minus 2. So the minus 2 means we're going to the right 2. So we want this basic shape, but just moved over. So the only one that keeps that same basic shape is the green one. So this is green. And then here we have 2 minus x. So the 2 is going to be a left 2. And then the negative is a flip. So we need to flip over something. So the only one that's flipped vertically is going to be the blue one. And then the next one here, we have a plus 2. So again, we're going left 2. And then we have a negative out front. So that's going to be a vertical flip over the x-axis. So the options are orange or pink. Pink looks like it moved up and down, so we can't do that one. So this is orange. And that leaves pink for the last one, which went up to and flipped. So here's your homework assignment. Let me know if you have questions.